students, in our previous class we have solved question number 1, 2 and 3 of exercise 9.2, and today we will solve the rest of the sums. So here is question number 4. So here is question number 4, and in this question a parallelogram is given, and given in this figure P is a point in the interior of this parallelogram ABCD. That is, P is a point, that is interior means inside of this parallelogram ABCD. Now we have to show that area of triangle APB. APB means APB, that is this triangle, plus area PCD, that is these two triangles. I have to show that this triangle plus this triangle, area of both this triangle is equal to half of the area of ABCD. This is half of this parallelogram. Next we have to show that area of APD, that is this triangle, plus PBC, that is this triangle, that is APB plus PBC is equal to APB plus PCD. That is sum of these two triangles, that is area of this sum of these two triangles is equal to sum of this area. So to prove it, we have to make a construction. That is, through P we have to draw a line which is parallel to AB. So if it is AB or BC same, sorry, AB and CD same, suppose E F. Now see, first given, that is P is a point in the interior of a triangle ABCD, it's given. So to prove this part, so we'll write like this. So here given P is a point in the interior of a parallelogram ABCD, and to prove this. So this part is exactly as the question. Next we have to write a construction. Construction part. So to make the proof easy, to make the proof easier, we draw a line. We draw a line EF through P. Through P we draw this line EF parallel to AB. So here you may write parallel to CD also. That is AB and CD both are parallel. Now see, in the proof part, see this triangle ABP and the parallelogram ABFE. So it's ABFE is obviously a parallelogram because AB is parallel to EF and AE is parallel to BF. So, and both this parallelogram and triangle has the same base AB and lies between the same parallels. Therefore, area of this triangle APB is equal to half of this area of ABFE. Now we will write it. So the parallelogram ABFE. So parallelogram ABFE, that means you can write, since AB parallel EF and AE parallel EF. That's why it's a parallelogram. So the parallelogram ABFE and the triangle ABP, or here APB is written, so APB lie on the same base AB and between BET dependence between the same parallels AB and EF. Therefore, again we use the result of exercise, example number 2. That is, if a triangle and a parallelogram lie on a same base and between the same parallels, then the area of the triangle is half of the area of this parallelogram. So area of APB, here triangle APB is equal to half area of ABFE. So give it equation number 1. So right, similarly parallelogram EFCD, here no need to write this part again. So and triangle PCD lie on the same base. So which is the same base here? CD is the same base. CD, and between the same parallels CD and EF. That is this two lines, CD and EF. Therefore, area of this triangle PCD. So in the question, this triangular symbol is not given, so we also not write. So half area of EFCD. So give it number 2. Now add these two. Now 1 plus 2 in place. So here we have two proofs. So give it as number 1. It's number 1. So 1 plus 2. So left hand side plus left hand side. Area of APB plus area of PCD is equal to right hand side plus right hand side. Right hand side is half area of ABFE plus half area of EFCD. This. So left hand side is same. It is area of APB plus area of PCD is equal to, so half and half we can take common half. So ABEFE ABFE. It is this parallelogram. This is the parallelogram ABFE plus EFCD. EFCD, this parallelogram. It is, if we add both this parallelogram, we get this whole. It is half area of ABCD. So this is proof number 1. So give it as number 3. So up to number 1 is the proof. Now we'll prove number 2. For question number 2, we have to draw this line from B but parallel to AD or BC. So in number 2, right, and here we have GH. Suppose we write this line as GH. So here, right, we draw a line GH from P parallel to AD. Parallel to AD, or you can write BC also. Same, AD and BC are parallel. Therefore, now AGHD becomes a parallelogram because AD and GH is parallel by the construction, and AG and DH are parallel because opposite sides have a parallelogram. That is part of this side. Parallel sides are parallel. So parallelogram AGHD and triangle APD lie on the same base. So which is the same base? So here AD is the same base. Same base AD, and between the same parallels, that is same parallel lines, AD and CH. Therefore, area of APD is equal to half area of AGHD. AGHD. So give it number 4. Similarly, here also GBCH is a parallelogram and BPBC is a triangle, and which have the same common base BC and lies between the same parallels BC and GH. So similarly, parallelogram GBCH and triangle PBC lie on the same base BC here. Same base BC, and between the same parallels. Same parallels BC and BC. So we write here parallels shortly. Therefore, area of this PBC is equal to half area of GBCH. So give it number Now 4 plus 5 implies. If we add this equation number 4 and equation number 5, that is left hand side plus left hand side, area of APD plus area of PBC is equal to, so area of half area of AGHD plus half area of GBC. So you can write here, but we'll write in short. So half and half common, area of, if we add AGHD, that is this parallelogram, this is the AGHD plus GBCH, that is the parallelogram. That is, if we add, we get the whole ABC. So we write directly A, B, C, D. So area of APD plus area of PBC equal to half area of ABCD. Now in equation number 3, that is in the proof of 1, we get that half of area of ABCD means APB plus PCD. So we can write area of APB plus PCD, area of PCD. So here using 3 you can write. So in bracket, right, using equation number 3 or using Roman 1, that is first question, you get this. So which is the required proof of this question. Okay. So our next question is question number 5, and in this question a figure is given, and here in figure PQRS, that is PQRS and ABRS are parallelograms, and given that x is any point on this side BR, x is any point on the side BR, that is x may be any point here, x may be here also, here also, here also, here also, anywhere. Now we have to show that PQRS and ABRS, that is area of both the parallelogram are same. So obviously both the parallelogram lies on the same base SR, this RS are both and lies within the same parallel lines SR and PB. That means their areas are equal. And next we have to show that area of AXS, that is area of this triangle, is half of this area of PQRS. Now we'll prove it. So first, given part is same and to prove part is the same. So here we write given PQRS and ABRS are parallelograms and x is any point on the side BR, and to prove area of this and area of AXS equal to this. That is, they are exactly same as the question. Now we will let the proof part. Proof. So proof first 1. So we have to write directly parallelogram PQRS and their parallelograms PQRS and ABRS lie on the same base SR and between the same parallels SR and SR and PB. Therefore, so by the theorem, so area PQRS is equal to area ABRS. So this is the proof only. Easy. Next, for number 2, AXS. Now we'll take this parallel only. See, if we take this parallel only, that is ABRS, and ABRS is a parallelogram and AXS is a triangle, and both this parallelogram and triangle has the common base AS, and they lies between same parallel lines AS and BF. So number 2, the parallelogram ABRS and triangle AXS lie on the same base. Which is the same base? AS. And between the same parallels AS and BF. Therefore, so by example number 2, area AXS is equal to half area of ABRS. So AXS is equal to half of area of ABRS. Now, but we have to show that AXS is equal to half area of PQRS. That means you can write half area of, see, here we get area of ABRS and area of PQRS is same. That is, in place of ABRS, we can write PQRS. Why? By 1. So in 1 we have already proved, that is area of AXS is equal to, in place of half of area of ABRS, we can write half of area of PQRS. So AXS is equal to half of area of PQRS. So this is the required proof. It's a simple proof. Next, question number 6. So question number 6 is, a farmer was having a field in the form of a parallelogram PQRS, that is PQRS, and she took a point A on RS. This is RS, suppose this is the point A, and joined it to points P and Q. That is, A is joined with P and Q. Now the question is, in how many parts the field is divided? So how many parts? 1, 2, 3. So 3 parts. Next question is, what are the shapes of these parts? So what is this shape? All are triangular shape. It is triangles. And next question is, the farmer wants to sow wheat and pulses in equal portions of the field separately. How should she do it? So she wants to sow wheat and pulses here. So this is a triangle APQ and PQR is a parallelogram. So if she saw wheat here, and pulses in these 2 regions, then the areas will be equal. So since the area of APB is equal to half of area of PQRS, so she can sow wheat on the area APQ and the pulses in the other two regions. So this is the answers only. So okay, thank you.